Properties. Okay, is that better? Yes. Okay. Sorry about that. The audio was done, and I was supposed to be doing it on Twitch, and I didn't. So now there should be audio. Hopefully it sounds decent. Thank you, someone, for linking to Twitch. That's very helpful. The title of this stream should be Calculus. R01, optimization. Why that doesn't show up at the beginning, I don't know. Calculus, tag. Somebody give me some tags here, right? Calculus, obviously. And for some reason, I actually have more simultaneous users on Twitch now than is in my largest class. Not sure about that. And people are apparently bored and watching me do calculus. Very strange people. So that was just an interesting side note. Now, yes, the bots. So people are like hunting for me. They're apparently finding out that I think, there's this. So there was this article that totally not related to class. There was this article that apparently that conservative guy who goes and hunts college professors has a thing where he wants to send students to go catch liberal professors saying things that they shouldn't online and posting the videos and going on, Fox News or whatever and saying things. And it is the dearest ambition of my life to get on this list of people that are, leftist professors. So, I need to make some Trump jokes or something. Just to emphasize the absurdity of the whole thing, of course. So if you see me make Trump jokes, please, by all means, go fill out the thing. Say I'm a horrible, leftist professor trying to enunciate, leftist ideology. Vote for Kennedy on you. So no, there's no attendance policy at all. I was going to do 1 and 4. But then people are watching the lectures and people are asking questions, and so I don't need to. And I don't want to do the overhead for doing the grading for that. You don't want to be bothered by the fact that, oh no, did I miss my 1 and 4? As long as enough people show up so that I can see I can see questions and I can get 1 to 5 responses, I'm fine, because that's really. And then if you want to ask questions, of course you have to attend the live lecture. And I don't care which one you attend. I don't care. I mean, I care that you attend one of them, but I don't mind so much if you don't. Okay, and it doesn't matter if you're in the 11 o'clock. It doesn't matter if you're in the 9:30. You may go to either lecture, no lecture, both lectures. It's all good. Yes. Are there any questions for me before we get started? All right. Some of them are coming up. Just out of curiosity, 1 to 5. How did the quiz working? 1 to 5. Getting on not 1 to 5. How do we feel about the quiz? I mean, 1 to 5, the whole process of taking the quiz. All right. So this is 1 to 5 process for taking quiz. Right. So getting Proctorio to work, getting the thing uploaded, getting the PDF, all that stuff. I'm not asking you about the quiz itself. I'm asking you about the process, because we need to talk a little bit about the process. Okay. And as you can see, that I now have a TA in the class with us, whose name I'm not going to mention on a public forum. And he is going to start asking for the polls. He'll be able to answer questions in chat. He will be able to do the 5-poll thing whenever I say 1 to 5. How do we feel about that? And that way, I can focus on the stuff I'm supposed to do, and all of that stuff. Let's see, any questions in here? So, attention to the live lectures. I already addressed that. I addressed that. Oh, proper way to submit it. By it, I mean I assume you mean the quizzes. The quizzes should be uploaded to Gradescope. And that's uh, the quizzes should be all uploaded to Gradescope. But you're supposed to be taking them with Proctorio active. So you go on that active quiz thing, enable Proctorio. If they're enabled uploaded in the wrong order, then the TA who has to grade them is going to go, why? And it is going to have anxieties about that. So any other questions about that stuff? Okay, so let's go over the quiz. And now I'm going to please ask your questions, but I'm going to kind of change the way that I'm doing this. I'm not going to just keep watching chat. I'm going to actually start doing this, and then I will, as it happens, be ready to do that. Okay, so the quiz. Use Fermat's theorem to prove Rolle's theorem. This caused a little bit more indigestion than I thought it would. It's probably because most of the proofs so far have been these long chains of equalities. We started with the two equalities here, and then we had to do it like this, and we had to do it like that, and it's a little bit, they're nice. They've got math symbols. This one is almost all words. That makes people unhappy. But let's talk about it. So I'm going to show how to use Fermat's theorem to prove Rolle's theorem. And the answer really is a whole bunch of words. The symbol to word ratio for this proof is about, I don't know, 10 words for every, 10 words for every symbol. So it really is, a wordy kind of proof. And these all are, they're assume otherwise. They're arguments. And a proof is just that. It's an argument. It's why must it be true? So what do we want to show? Well, we want to show that if f is continuous and differentiable on AB, and if f of a, that should be an A, not a C, f of a equals f of b, then there exists some u in AB such that f prime of u equals 0. And then my u looks like an A, doesn't it? I should be a little neater. Okay. So our strategy for doing this is going to be assume otherwise and hunt for the min and max, finding the contradiction. And then I'm going to name the two theorems I need, right? Because this is the bit that I memorized before the test. Assume otherwise, hunt for the min, hunt for the max, find a contradiction. I need the extreme value theorem, and I need Fermat's theorem. So this whole bit about using Fermat's theorem to prove Rolle's theorem, should I have said use EVT and Fermat to prove Rolle's theorem? Maybe. But what I was doing here was just trying to give you a little hint. Hey, you need Fermat's theorem. You can do it. I did it with the contradiction proof. There's another proof in the book that does a proof by cases. I didn't do that. I think that one's boring. This one's a little bit more fun. They all come down to basically the same thing. But then this is more like the proofs that you use in order to, when you use it. So I did it this way. And it's a bit more fun. So I start my proof. The body is simple, is the beginning. Suppose otherwise. Suppose f is continuous on AB, differentiable on AB, and f of a equals f of b. But there is no u in AB, so that f prime of u is equal to 0. Since f is continuous on AB by the extreme value theorem, f must have a min and a max for that interval. Let's call u the x value. You don't have to do this. You could have just said let u, you didn't have to say u at all here. You could have just said what if the max occurs in the middle. I did a little bit more here that was a little bit different than I did when I did the proof the other day. I changed the wording a little bit, and that's fine because I still get the point across. Call u the x value so that f of u is the maximum. If u is in the middle, then by Fermat's theorem, since f is differentiable in the middle, f prime of u equals 0. So u must be one of the endpoints. Likewise, if the min occurs at the middle, the derivative is 0 there, so the min must be at one of the endpoints. But f of a equals f of b. The endpoints are equal to each other, implying that the maximum and the minimum are equal to each other. Well, that means that the function was constant everywhere, and that means that the derivative was 0 everywhere. That's absurd, right? Because I assumed that there was no place where the derivative was 0. So I've reached a contradiction, so there must be a u in AB so that f prime of u equals 0. How do we feel about that 1 to 5? Oop, there we go. So how do we feel about this 1 to 5? Yeah, I know the quiz is going to be fun to grade. Let me put a like on that one too. All right. Yes. So let's look at the questions here. We've got questions about the stuff. Noah answered. Noah answered. Noah answered. Excellent. Thank you. Yes, you can use the proof by cases that you find in the book. That's perfectly fine. I think it's boring, but it's good. I see a lot of 2s on this. How do we feel about the idea of just finding a contradiction? So 1 to 5, how do we feel about just the idea that I can just find a contradiction? Just the idea that what I'm hunting for is some contradiction. Okay. All right, so the whole idea that I could prove things by showing that if I assume otherwise, I wind up with something that's absurd. In this case, the absurdity was that I assumed that there was no place where f prime of u equals 0, and that led me to the consequence that the min and the max had to be at the endpoints. But since the endpoints are equal, that means that the function itself was a constant function, okay? And if that's the part tripping you up, just go ahead and think about that. What does it mean if the max and the min are equal, okay? So if the max and the min are equal, let's add some pictures to this. So if u is in the middle, right? I can't have this. Okay? Likewise, if the min occurs, I can't have that. So that means what I have is this situation. But there, f prime of x equals 0 everywhere. Okay? And I know my big fat head is probably in that picture. Okay? So yes, so there were two ways to get at this. Yes, you can do the proof by cases that's in the book. And it's at the beginning of that section in the textbook. So that's section 4.2, and the proof by cases is on the top of page 211. And the proofs are actually very similar. It's just that in one of them, you in one of them, it's kind of a you just show what happens in each case. And you have to make sure that you've exhausted all the possibilities. On the other one, you're doing the same thing, except you're kind of just hunting through them. So that it's both proofs work, but this proof is more like the problems. Okay. Any other questions about that? So let me look at all these questions here. Do we have to do something like this on the test? I guarantee some problem that will get you. I guarantee a proof on the test. So we've done, how many proofs have we done so far? We've done this proof. We did the proof of the mean value theorem using rolls. We did the proof that if two functions have the same derivative, then they differ by at most a constant. Those three proofs, expect a bunch of them. All right, and yes, expect a big proof, and this could be one of them. And I'll talk more about the test when the final version comes down. We wrote it this weekend and finalized it yesterday, but it won't be finalized until they yell at each other. So, stuff like that happens. Okay. Let's move on to question 2. And this is what I mean by the strategies kind of being the same. Do you believe Marvin the Martian? Do you agree or disagree? If you agree, prove it. If you disagree, prove the statement is false. I said Marvin is wrong. Assume otherwise. Assume otherwise. If I assume otherwise, then this function has at least two different roots. So let them be A and B. Okay? And so I've got f of A equals 0 and f of B equals 0. Well, f is continuous and differentiable everywhere because cosine is continuous and differentiable everywhere, and 2x is a polynomial, and I'm slamming them together. So if I take two continuous and differentiable functions and add them together, what I get is something continuous and differentiable. So by Rolle's theorem, there must exist a u in AB, since f of A equals f of B, so that f prime of u equals 0. Okay. Well, f prime of x equals 2 minus the sine of x. And the maximum of sine of x is 1. So f prime of x, the smallest f prime of x can get, is 1, right? It's 2 minus 1. And 1 is never 0. So f prime of u must be greater than or equal to 1. And that's a contradiction, right? Contradicting the assertion that f prime of u equals 0. Therefore, he's wrong. Okay. So Let's look at questions about this. 1 to 5, how do we feel about this one? And that one's very similar to a problem that was in the book, and it's very similar to one I did last time, the first one I did last time. So how do we feel about this question? Very nice. I like the I don't believe you question part. Yes. Very nice. I like that. Okay. So this whole thing about proofs by contradiction, people, yes. So people seem a bit uncomfortable with it. Okay. So what I'll do is I'll put a couple more of those on the bootleg when I put it out, and on the study guide, so you'll get a little bit more comfortable about this. You can do these things a slightly different way, but they both boil down to the same thing, right? They both boil down to the fact that this thing can't happen. Now, uh, on you, I mean, there's nothing else to say about it. That's just how these problems kind of work. So I've chosen, as I said before, I've chosen to actually do the proof by contradiction stuff formally instead of kind of just hand waving it and saying, "Oh, you'll miss that problem on the test." I'm actually trying to do the whole thing. You know, if you hate me, you hate me, and I guess I'll just have to be sad about that. Any other questions? Okay, name one thing you found memorable from the last class. Hey, the tech worked this time. Um, Knock on wood. Um, any other questions before I move on to the new material for today? People are typing new questions. Uh, okay. Uh, Questions aren't coming up yet. They're typing them. Can we plug in values into the function? No, you can't. And see the graph was. No, I mean, that's a good way to think about the problem and nice way to visualize it, but you can't prove it with that, okay? Because there's this idea that there's an infinite number of points I would have to check in order for that to work, okay? Um, so no, you can't just do it by example and by look at the graph and it's obvious. You actually need to show that it cannot happen. And the way that you do that, there's two ways to do that. The first way is to say what I did. The second way is to make the assertion that this function's always increasing by saying that the first derivative is positive. You show that the function's always increasing. And then you use another theorem from that section to say, and by this theorem, therefore it has only, it can only be 0 once. But that involves actually using the technical definition of increasing and decreasing, which I didn't do. But you can do it that way, but you have to be very careful with the technical details. This is more like, the details are less important here. What's important is the big idea. Well, assume otherwise. So part of it is the type of person you are. I'm not the most detail-oriented person in the world. So I kind of like these because they're big picture proofs, right? The other way of doing these things is super, super detail-oriented. This, and I find those proofs very dry. Part of that style, but part of it's also that you don't see. It's very easy to lose the forest for all the individual trees. If you want, you can come to the practice session today at 5, and if you want me to go over the other ways of doing them, I will be happy to do it. But I think you will actually find this better once you let it work on you. And I know it's big and hard. I know it's hard, but it's if you can get this idea, this big picture idea. I assume otherwise. You will be happier in the long term, I think. unless you're one of those really detail-oriented people who can keep track of everything. I can't. All right, so and then of course the last question. Yes, whatever that. Okay, so let's talk about optimization. This is kind of the whole point of what we were doing. The whole point was to get here. Last time we did a bunch of proofs. You all hated them. That's okay. It's not okay, but it's what it is. And then today, basically, we're going to math our way through economics by doing optimization problems. Now, the book does a whole bunch of mathematical optimization problems, and then it does a whole bunch of mathematical optimization problems. It does some physics example. It does Snell's law. All of those are nice, but it's not really focused. What we want is to focus our attention on these problems. And the way to do that is just to keep in your mind that things cost money, okay? So I can't have everything, you can't always get what you want, but if you try, sometimes you get what you need, et cetera, et cetera, et cetera, Rolling Stones. But that should actually be, the title for the next quiz. You can't always get what you want. But the question is, what can we get? What's the maximal amount we could get for a given amount of money? Or, if I need to get to a particular thing, what's the least amount it will cost? And so today's big idea, if you think about two things. One, draw. Three things. Draw. What costs money? Take the derivative and set it equal to 0. And the big thing about these problems, and then there are details like I need to check to make sure I actually have answered the question, blah, 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 blah. Details, details, details. The important thing here, okay, is to keep these things in mind. That the setup is the hard part. Now, I've actually talked more about I've yacked more than I should have. Let's just jump in here. So every spring, except of course this spring because it's COVID season, there's this thing out at Mosey called the Renaissance Fair, and a bunch of people who like to perform, like to dress up in armor and go beat each other with swords. People do various other things like crafts and whatnot, what have you. Some people like to dress up as elves. I don't know why people like to do this, but they like to go to the Renaissance Fair. Have a good time, eat a turkey leg, and drink some mead. Now, they want to set up a rectangular area for employee parking. Bring in your carriage and stuff like that. 3 sides of the area will be visible to patrons, so the fair will use theme fence for those sides. And that theme fence costs $20 for foot. However, the north side can't be seen from the guest area, so we'll just use chain link fencing at $10 a foot. If I have a $1,200 budget for fencing, what are the optimal dimensions of the lot and how large will it be? In other words, how much bang can I get for $1,200? How much bang can I get for my buck? What's the biggest area that I can build with these parameters? Okay? And there are other ways of, introducing this topic. And you'll do a different one in peer leading. But this is just kind of the big idea. How do we feel about the problem setup? What it's asking, 1 to 5. Ah, oops. All right. So how do I do this? How do I do this problem? Well, let's look at our things. Let's draw it out, okay? And let's ask ourselves, what is costing money? All right. So let's draw it. Since I'm now at the computer and not on the board, I can do perfect shapes. Watch me draw a perfect rectangle here. Okay. Well, maybe not, because the thing's not syncing now. Okay, now we've had our little failure. Ah! Ha! Technical failure solved. Okay. So I'm going to draw a picture of this lot, right? And let's see, 3 sides are going to cost me $20 a foot. So this side here, and let's call this one a $20 side. This side here is a $20 side. And this side here is a $20 side. And this side here is going to be chain link fencing at $10 a foot. Okay? Now, the biggest bang for the buck. What does that mean? Okay? That means what? So what does that mean? What am I trying to maximize? What am I trying to get the most of? Is it length of these fences? No. I'm trying to get the most out of my money. And the most out of my money means the area. All right? The lowest price, but I've got a fixed budget. And what I want, because this is how budgets work, you have to spend all the money. So I want to maximize the area contained within the fence, right? Most space for the lowest price. That's a good way to say it. Okay? So what I want to maximize is the area of this rectangle. Well, what's area? So what is the formula for area? Right, and you know how budgets work in departments, right? They give you an amount of money, you don't give them back any of the money because then you get less money next time to do the problem. You have to spend all the money, right? That's very important. Now, it's not a square, it's a rectangle, right? So that's length times width, okay? Area equals length times width. So I'll call this L, I'll call this side an L, and I'll call this side a W, and call this side a W. Now, the question, what costs money? Fencing. How much money? Well, it's going to be $20 times whatever this side is, right? I've got so much fence, this side, so at $20 a foot, this side here is 20 times L. That's how much that side is going to cost. This side here is going to cost me 10 times L. This side here is going to cost me 20 times L. I'm sorry, not 10 times L, 10 times W. This side here is going to cost me 20 times L. And this side right here is going to cost me $20 times W. Everyone on board with that? 1 to 5, how do we feel about that? So my total cost here, I've got this side over here. I just did it again, didn't I? And then I'm just going to sum these things up to simplify the equation. So I've got 40Ls plus 30W. And my budget, the cost, equals $1,200. Now, it's important to note that it could be the fact that I might have a fixed area, right? So it's not necessarily the budget that's fixed. It could be that the area is fixed, and I need to find out what's the minimum amount it would cost me to get it, right? That's a similar problem, slightly different, but similar. So it's not necessarily that one of these is going to be constrained, okay? One of these is going to be constrained, and then I have to create one equation. So what I'm going to do, I've got area equals length times width, right? And then I've got this equation here. So now I'm going to wind up with two equations. I wind up with the equation A equals L times W, and I wind up with the equation 1200 equals 40L plus 30W. Okay? And now what I'm going to do is get one equation. Okay? So I want to be able to look at all of these equations, and I want to be able to get one equation that I can minimize and maximize. Okay. All right, so let's pick one of these variables. First thing let's do, let's divide through on this equation here because the numbers are awful. Let's get rid of a 10. Okay, and then let's divide through by 4. No, 3. Nope, that's all we can do. So now I've got 120 equals 4L plus 3W. I'm going to solve for L here, and I'm going to wind up with L. I know my face is going to be in the way. Hold on. L, so let's see. If I move this over to this side, I get 120 minus 2, 3W equals, and then divide through by 4, and I wind up with L. So all I did was solve for one of the variables, and then I'm going to throw it back in this one. And so my final equation is going to be A equals 120 minus 3W over 4 times W. So all I did there was substitute in for L. Right, and that's where those things came from. How do we feel about that, 1 to 5? And let me stop. Are there any questions about this? And when I say, are there any questions, what I actually mean is I'm looking in the chat for questions you have. Okay, so we feel pretty good about this, it looks like. What's the thumbs down for? Are we unhappy with me? This is making me sad. You're hurting my feelings. Okay. All right. So now I have this one equation with one unknown. Well, what can I do? I want to maximize that equation, right? So how do I maximize an equation? So here's what that equation looks like. Let me do this. So here is what the equation ends up looking like. Okay? This is what happens. Now, I used X and Y because I used X and Y here, but this is what I want to do, right? I've got this equation. This should be an A. This should be a W, right? I've used Y here because, I have to tell Desmos Desmos wants the independent variable to be Y. But if we look at this, right, there's some point here in the middle. Whereas if I set the if I set W equal to 20, this graph is telling me that I'm going to get an area of 300. Okay, and that's the biggest I can get, right? Because if I go over here, I'm going to if my width is, let's say, 10, I'm only going to be able to get an area of 225. And likewise, if my length is 30, I also wind up with an area of 225. Okay? So what I want to do is I want to put area in terms of only one variable, because then I can make a graph here. This axis right here is area. This axis, which you can't see me actually point to the screen. That's nice. Let's see. Can I add? How do I add label axes? There's a way to do it. Oh well. Nope. Okay. Anyway, there is a way. Ooh, copyright. Thank you. Graph settings. X-axis, Y-axis. So this is area, and this right here is the width. Okay. So there's area here on the Y-axis. There's width. Okay. And so that's the way this thing looks. So what do I do to find this maximum point? Well, I set the derivative equal to 0 and find out where that is. So let's do it. So let's do a little simplification first. Let's do this. Let's multiply this out. Oops. So this becomes 120 over 4 minus 3 over 4w, all times w, which equals 30w minus 3 over 4w squared. All right. I assume my math is there, correct? And then what I'm going to do is take the derivative of this. So a prime, or dA over dw, I could do that, equals 30 minus 2 times 3 over 4 w to the first. And that equals, we'll do a little cancellation, that equals 30 minus 3 over 2w. And I'm going to set that equal to 0. Okay? So since I'm finding the place where the maximum is in the middle, I'm going to set the derivative equal to 0. And now I'm just going to solve it. I'm going to solve now this equation right here. Okay? So I'm going to move the 3 halves w over to the other side. I'm going to multiply both sides by true. So I'm going to wind up with 30 equals 3 halves w, which implies that 60 equals 3W, which implies that W equals 20. Okay, now that's all well and good. Now I throw W back into my equation here, and I get that implies that L equals 120 minus 3 times 20 over 4, which equals, and I'll even call these L star and W star. These are the optimized values. 3 times 20 is 60, so that's 60 over 4, and that is 15. Yes. So it turns out that this dimension, the optimal size of this thing, right, is 20 width and 15 L. And now I need to put some dimensions on it, but there's one thing I need to do first. And that is check to see how much time I have left. I'm probably over already. Oh, no, I'm not. I got lots of time. Okay, cool. Beans. We're cooking. Okay. So the point of this is that now I've got these two things, right? And I need to put units on it, and I need to say what the optimalist area was, right? So that means that A star equals 20 times 15, which equals, brain dead. My brain just went, no, 300. This should be a feet. This should be feet, and this should be feet squared. How do we feel about that, 1 to 5? And do we have any questions so far? Okay. One little detail. I need to check to make sure I have a max. And there are a couple ways to do this. Okay? No, that is not a double prime. This is an A star. The double prime is about to happen. Okay? A star just means that that's where I had the thing. I'm about to do a double prime. Okay? I need to check the max. There are a couple ways to do this. Okay? The first way is I take the second derivative and I find out if it's positive or negative. Because if the second derivative is negative, I'm concave up, I have a max. Okay? Second derivative test. Okay? I could have done the first derivative test. All right? First derivative test. Alternatives. You could have done first derivative test. You could have just checked the endpoints. Okay? All of those things are true. Okay? Endpoint check. If W equals 0, A equals 0, so that isn't it. Derivative, sorry, A only has one critical value. So that is the max. Okay. So I just checked the endpoints, right? I'm looking for an absolute max on the thing, and I just checked the endpoints. Alternative, I could have done the first derivative test. All right, here is W equals 20. So I picked two test points. Easy test points to pick are W equals 1 and or W equals 10. So let's do test points 10 and 30. And then A would be A prime at 10 would be where's A prime? A prime at 10, 30 minus. So here I have 30 minus 3 over 2 times 10 would equal 15. Here I would have 30 minus, which is positive. Here I would have 30 equals 3 over 2 times 30. I'm sorry, 30 minus, not equals. Which would be 3 times 30 is 90 over 2 is 45. So here I have something that is positive. Here I have something negative. So my function looks like this. And I have a max. Okay, so that's the first derivative test. You have to do one of these. Okay, how do we feel about that 1 to 5? I just need to check to make sure I have a max. Or a min if I'm looking for a min. 1 to 5, how do we feel about that? Oh, there we are. Okay, right. So let's do one with a min, okay? So here, I just need to check something. I just need to do one of these, right? So I've got units, I've got a nice little picture. So I've got my final answer has units. Let's go back and make sure I answered the question. The question was, if I have a materials budget, what are the optimal dimensions of the lot and how large will it be? So yes, I've answered the question, correct? So go back and check to make sure that you've answered the question. Okay. Just, make sure. Okay. Yes, so the 15 and the 20 would be the optimal definitions. So the question is asking you, okay, so the question in chat is, why do we need to find a min or a max if the question doesn't ask for that? It does. The question is asking for the optimal size of the parking lot, okay? If I wanted to maximize the size of the parking lot, right? What are the optimal dimensions of the parking lot and how large would it be? By optimal, I mean maximum or minimum, okay? So that is what the question asks. I could have reworked this question. If the fare is what's the largest parking lot, what is the largest parking lot? If I wanted to rephrase this question, I could. If that makes you feel better, I could reword the question so that it, um, so that that's the way it's phrased. What's the largest parking lot I can build? What's the optimal size of the parking lot? And so that's what I'm looking for. I'm looking for a max and a min. Okay. Here's a related question. Let's ask the same question again, but let's do the opposite. Let's say I need a 600 foot, I need a 300 square foot parking lot. How much will it cost me? What's the least amount I could spend to do it? So let's ask the exact same question. Exact same question, okay? So I'm not sure if I'm going to get to this problem. I won't. This is a cool problem, so I'll put it in there, except I can't spell maintenance. I spelled it wrong twice in two different ways. Maintain. There we go. Okay, so the setup for this particular problem is the exact same thing a little bit, except now I want to minimize. So we've got the exact same setup for this bit. There we go. This whole bit here is exactly the same. Okay? Except now I don't have a budget. Okay? Now instead, I need a fixed area. So this stuff goes. Okay? And I need my area. This is the new part of the problem here. So now, instead of trying to maximize area, I want to minimize cost. Okay, so how do we feel about how the question has changed, 1 to 5? All right, everything else in the question remains the same, except now I want to minimize the cost instead of maximize the area. Okay. All right, let's look at this. All right. Now I'm going to have two different equations. Now I'm going to have A equals L times W, but that's the thing that's fixed. And I have C equals 40L plus 30W. But this now this is now the equation I'm optimizing. And the other, so this is now the equation I'm optimizing, and this is the equation that's fixed. Above, right? Above it was different. Above, what I was doing was I was optimizing the, come here. Above, what I was doing was I was optimize U, and you were fixed. Okay? But now I've changed which one's which. Okay, so let's do this one. Now what I'm going to do is I'm going to substitute this right here. I'm going to have 300 equals, oops, I want a different color. 300 equals L times W, which now implies, excuse me, which now implies that L equals 300 over W. So now I subs that in here, and I get C equals 40 times 300 over W plus 30W. Okay? So now what I've done is I've taken this thing and combined it with this thing here, and I get that. And what I'm going to do is take the derivative, set it equal to 0. Okay. So when I take the derivative of this, okay, this right here, this top bit, let me just write it out one more time, is 40 times 300. I hate that. I see this 30 here. So what I'm thinking is maybe stuff will cancel after I take the derivative. So I'm going to leave 40 times 300 like it is, but I'm going to take W. I'm going to take a W to the negative 1. So these are just constants being multiplied. And this is going to become a W to the negative 1. And this is going to become plus 30W. Now, the reason why I'm doing that is because when I take the derivative and set it equal to 0, my guess is that that 3 and that 300 are going to, I'm gonna cancel some stuff out. So I'm thinking that there's going to wind up being a 30 in here when I take the derivative and set it equal to 0. So I'm just going to leave it. Okay. So that means that C prime equals 40 times 30, 300, times negative 1 times W to the negative 2. And it should be emphasized that that's a times, plus 30. And now I'm going to set that equal to 0. All right. And as I said, there was a reason why I left that 30 in there, because it turns out I'm right. When I do that, those 30s are going to cancel out nicely. So I'm going to wind up with 400 times, I'm going to wind up with 30 minus 400 times 30 times W to the negative 2. equals 0. And that gives me that this stuff, so I'm going to cancel out that 30 in just a moment. This stuff all moves over to the other side, and I wind up with 30 equals 400 times 30 over W squared. And those 30s now cancel. The one on the left becomes a 1. And that implies that 1 equals 400 over W squared, which implies that W squared equals 400. Which implies that W equals plus or minus the square root of 400. Why don't I care about the negative? Why don't I care about the negative, guys? Is nobody watching anymore? It's purely possible. Okay, so why don't I care about the negative? Because the width. Right, because I can't have negative width. I can't have negative area. Why the 300? No, I moved the 10. Sorry, this became 400 times 30 because I moved the 10 around. Okay, so the process I did was this. Let me do it without the little algebra trick right there. Okay, let me do this one more time just to see this. All right. Here I have, right here, I have 40 times 300, okay? And here I have a 30. Now this 30 right here is going to be moved, is going to become the thing in front, okay? So I have this big negative number here. Would it make you happier if I moved the 30 over now? So let's do that. Let's make the algebra a little bit happier. There's a negative 1 here, right? So what I'm going to do is I'm going to add 30. I'm going to add this whole term to both sides. And I wind up with 30 equals 40 times 300 times W to the negative 2. Okay? Now I'm going to divide through. Now what I'm going to do is I'm going to cancel out the 10 and the 3's. So I divide through by 10 and I get 3 and I kill U. Then I'm going to divide through by 3, and this whole thing becomes, right here, this becomes a 10. So I divide both sides by 30, and I wind up with a 10 then. Okay? And I wind up with that. And then I multiply both sides by W squared, and I wind up with W squared equals 400. And that gives me that W equals 20, and that would be W star, because that's the optimal. Okay? Now, I plug that back into my original equation, and I get that, okay, so I had then plug back in, and I get 300 equals L times 20, which gives me that L star equals, little mathy, 15. Okay. So now the question is, let's get rid of the apartment complex problem because I'm not going to get to it because I'm now out of time. How do I get back my original cost? Well, my cost was 40L plus 30W. So that means that C star my optimal cost equals 40L star plus 20L star. I just solved for that, which is 40 times 15 plus 20 times 20. I screwed it up, right? No, 30W. Which equals, 1,200 dinero plus a little American money too, as Chevy Chase would say. Now, I do the second derivative test to make sure that I've minimized my cost, okay? And I get that C double prime equals negative 2 times 40 times 300 times the negative 1 times W to the negative 3 plus 0, which I actually don't care what the number is. All I care about is the fact that those negatives cancel. And I wind up with something that is greater than 0. So I found I'm in. Okay, how do we feel about that? 1 to 5. All right. So play with these. I gave you some on WebAssign. I don't get confused by the ones in the book. Stick to one model in your head, right? There are all these distance problems and all of these types of problems now. Stick to one particular model. Think about what costs money. Draw your picture, set it up properly. It's the setup that kills you on these problems, right? The hard part of these problems is always the setup. So if you can get the setup right, you can get the problem. All right. Any other questions, comments, issues, suggestions, or thoughts? Okay, so the point of taking the second derivative is to make sure I have a minimum or a maximum. So I found an optimum, but I don't know if that optimum actually minimized it or maximized it. Okay, so I want to check to make sure that I've actually found the minimum or the maximum. Okay, and that's why I'm taking the second derivative. I want to check the concavity of the thing. Is it concave up or concave down? If it's concave up, I found the minimum. If it's concave down, I found the maximum. Okay, so it's just the second derivative test. Okay, I've run a little bit over, and I'm sorry about that. I'm trying to fix it. So I went 54 seconds over on time because I must have started just a slightly late. Oh yes, because I had the audio issue. If you what if it fails the second derivative test? That's a good question. If it fails the second derivative test, draw a graph of what's going on. Because it could be that the maximum or the minimum occurs otherwise, and it could also be that the maximum and minimum are 0, or one of the endpoints. And you can't have issues where the thing happens at an endpoint. Or it means that you did something incorrect. Either way, go check the setup, go check everything. Make sure that you're actually answering the correct problem. And then if at the end of the day you can't figure out what you did wrong, say this makes no sense. I did something wrong, because that gives you more points. But don't say that, of course, if you did it right. Because if you did it right and then you say you were wrong, we're going to be like, you're hedging your bets, and we're going to take off some points for that. Any other questions, comments, issues, suggestions, or thoughts? Okay, so look at this problem on your own time after class. I will post notes. I forgot to put some notes last time, but I need to post all the notes, and I will do so. I got the export thing to work again. Any other questions? Okay, that's it for me. I'm going to get in audio chat, and I will be able to answer any questions that you have between classes.